Hi everyone, welcome to TQS. In this video, we will introduce the features available in the system for the design of reinforced concrete columns and shear walls. In TQS, you can define columns and shear walls with rectangular, circular L, U, and polygonal cross-sections. It is also possible to define cross-section, material, and cover variations along the column height. Use high-strength concrete, model-inclined columns, steel or precast columns, and slender columns with the slenderness ratios up to 200. Columns are modeled as bar elements in the building space frame model, considering approximate material and geometric non-linearity under both vertical and horizontal loads. Shear walls can be discretized into bar meshes. In this space frame model, both first and second order global effects are calculated, and also the effects of global geometric imperfections are obtained, considering the normal force and bending moments of all load combinations of ultimate limit state in the design. These load combinations are transferred from the space frame model to the local analysis of each column segment. Information for the bracing in both column directions is automatically extracted from the global model for use in the local analysis. The local analysis computes local second-order effects, local geometric imperfections, and creep. For shear walls, localized second-order effects are considered for each discretized strip. For the calculation of the second-order effects in the local model, approximate or refined methodologies specified in the codes can be adopted. For material nonlinearity, you can use approximate formulas for stiffness or moment curvature relationships for each section, and for geometric nonlinearity, approximate approaches or local p-delta can be adopted. Once all internal forces are obtained, the longitudinal reinforcement is designed for combined biaxial bending and axial load at the critical sections of the column. A possible reinforcement layout is selected for each of the available bar diameters, meeting all code requirements for maximum and minimum reinforcement ratios and spacing. The anchorage of longitudinal bars is automatically calculated both between the column segments and at the foundation. Splices can be detailed using offset bent bars or mechanical couplers. The transverse reinforcement is automatically detailed with ties and cross ties, respecting spacing requirements. Ties can be closed or open, and the cross ties can be of various shapes. The transverse reinforcement can be detailed with different spacing in the following situations: at the intersection with beams, in the lap splice region of longitudinal reinforcement, in columns with high-strength concrete, and in segments subject to vehicular impact. The drawings for all columns and shear walls of the building are generated automatically and can be grouped with multiple stories or with each story drawn separately. A summary report is generated that allows for the evaluation of reinforcement ratios, detection of the most loaded and slender columns, facilitating the identification of critical load combinations for designing the column segment, as well as all calculation details. The system includes a specific graphical editor to assist with the design and detailing of columns and shear walls. It allows you to change any type of reinforcement and perform the local analysis using any available method. Shear walls, as they are surface-like elements, are treated differently in TQS. They can be composed of several strips, common in rigid cores of tall buildings. They are modeled by a mesh of bars representing the strips, with full control over their discretization, with bending and torsion being analyzed. The design and detailing of their reinforcement takes into account particular effects, such as localized second-order effects at their free ends. Columns subject to vehicular impact are designed considering the horizontal force generated by the collision in ultimate limit state load combinations for extraordinary events. For the verification of special columns, the material and geometric nonlinear frame is available. This model allows for the consideration of other types of support conditions, loads along the column length, and variable cross-sections. The final first-order and second-order forces are calculated considering the material and geometric nonlinearities in a refined way. All columns and shear walls calculations in TQS are configurable via numerous design criteria. To learn more about TQS, visit our website. Thank you.